Okay, let's give you guys a Calculus 1 optimization problem. So here you've got a straight line where the intercept is 10 and this is also 10. So you've got a straight line here, and this line here is 10 and negative 10. Your job is to find the value of x that will give me the biggest rectangle inside this triangle. So for example, you can vary x, so you can vary the location of x. So as you vary x, the area of the rectangle changes. So here I hope you can see the rectangle is really small, the area is really small. It gets bigger and bigger and bigger and bigger and bigger, and then it gets smaller and smaller and smaller. So somewhere in between the two there's going to be a value of x that will give you the biggest area of the rectangle. So find that that location x. So find the location x which will give me the biggest area. So press pause and have a go. Okay, so to do this, your job is to come up with a formula that for given x, you can work out the area. So for any given x, this length here will be 2x. So the area would be 2x times the height. Well, to work out the height, you need the equation of this line. So our next step is to find the equation of this straight line. Well, any straight line will have the form y equals mx plus c. Well, the intercept here is 10, so we know the c is 10, and the gradient is 10 divided by 10. It's going downhill, so it's going to be a negative 1. Well, the equation of this line is y equals 10 minus x. So I'm expecting you to know how to come up with the equation of this straight line. So let's start again here. The area, this area here, is given by, depending on where x is, it doesn't matter, let's just call x. This length here will be 2x, and then the height, well, if you know the location, the height will be given by this, because if you put this value into here, then it will jump to the line. Well, that height there would be given by 10 minus x. So this thing here is really the height of the rectangle, and 2x is the length. So the area is given by this. So the area is given by this. And then if you multiply this out, this times this, this times this, it will give you this. If you sketch this graph, when x is small, it wants to do a straight line. Y equals 20x. Remember, the intercept is 0. And when it's big, it wants to do a negative quadratic. So overall, your graph will look like this. Well, we're trying to find the biggest area of the rectangle, so you want the highest point here. If you're trying to maximize the area, find the highest point. So to find this highest point, what's so special about this highest point? Well, at the highest point, the gradient dA by dx, the gradient, will be 0 at the highest point. So given this, to find the highest point, you need to find dA by dx. So differentiate it. So when you differentiate this, it will give you 20. Differentiate this, it will give you 4x, negative 4x. And then to find the highest point, well, the gradient here will be 0. So put 0 into the dA by dx. So that will then give you this, and work backwards to find the value of x. So at this point here, it will have a gradient of 0. So find the value of x where the gradient will be 0. So our next task is to solve this. So hang on. So now add 4x to both sides. That will then give you this. Divide by 4. So x equals 5. So what that means is at x equals 5, the gradient will be 0, meaning it will give you the biggest area at x equals 5. So what that means is, back to our original problem, when x is 5, it will give you the biggest area. So the answer is x equals 5. When x equals 5, it will give you the biggest area. So what that means is, as you vary this, when x equals 5 right here, that's your biggest area. If you move to the left, that area is actually smaller. If you move to the right of 5, this area is actually smaller. The biggest area is x equals 5. Okay.